Okay, in today's lecture, I am going to cover data transmission. Okay, data transmission. Previously, we have covered all the analog modulation, analog transmission. Now in this term, we will cover the digital modulation. Okay. So please prepare your notes just with me only. So first of all, there is some definition I need to write. The output of a PCM system is a string of ones and zeros. Is a string of ones and zeros. Basically, what is a PCM system? It is a pulse code modulation. Okay. When we speak about the pulse code modulation, we basically deals with the digital modulation. Okay, these are of different types: PAM, PWM, PPM, that we will take it further. You all know what PCM, we have discussed it previously as well in the table when we were discussing the digital modulation and the analog modulation. Okay, but if these ones and zeros are to be transmitted over copper wires. Okay, see, when we are doing any transmission, it cannot go in air, right? Like suppose I want to send a message from my mobile to another mobile, it cannot transmit through air. It transmits, the data transmits through the wires and the transmission lines. We have put all the distribution lines, power grid lines, so the data transfers over those things. So they can be directly transmitted as two voltage levels. They can be directly transmitted as two voltage levels, which are plus V and minus V. So what does that plus V and minus V indicates? Basically, plus V is high voltage, minus V is low voltage. That means ones and zeros. Okay, but if these needs to be transmitted, these needs to be transmitted through space using antennas, okay, then some form of modulation has to be used. Has to be used. Okay, so there are different forms of modulation techniques. These modulation techniques are what we are going to study in this chapter. The first one is ASK, the second one is FSK, and the third one is PSK. So ASK is amplitude shift keying. Next is frequency shift keying. And the third one is phase shift keying. Okay, these are the three: ASK, FSK and PSK. Now we will just do the waveforms of these three: amplitude, phase and frequency shift keying. So the first one is, I'm putting the heading amplitude shift keying, which is known as ASK. So when I am talking about amplitude shift keying, I am speaking, it is a method which converts digital signal to analog signal. Okay, remember, now we are talking the digital signal and we are converting it to the analog signal. Okay, so basically definition, what is the definition of ASK? The amplitude of, when I am speaking about ASK, that means I will be speaking about the amplitude. Okay, the amplitude of carrier signal. You all know we have discussed the carrier signal, the modulating signal and the modulated signal in the previous term. Okay, so now I am speaking about the carrier signal. The amplitude of carrier signal varies with respect to amplitude of message signal. Okay, so let us say this is my MT. MT is your message signal. Okay, and this is my, here I can say this is carrier signal, which is CT equals to cos omega CT. That means message signal is going, okay, carrier signal is going through a mixer, and I am getting what? I am getting phi ASK. That means a amplitude shift keying signal. Okay, and now please remember the message signal will be in digital form, not the analog form. Okay, because we are talking about PCM techniques or the digital modulating techniques. Okay, now let us take an example of a waveform, because the message signal is a digital waveform. Okay, so I am just making a digital waveform here. A simple digital waveform in 0101 form. Okay, so can I write the numbers here? What is this? It is 0, this is 1, this is 0, this is 1, this is 0, this is 1, and this is 0. Okay, next will be my carrier signal. You all know the carrier signal. What will be the carrier signal? We already did the carrier signal in the previous classes, in the previous term. So carrier signal can have any frequency. Okay, it can have low frequency, it can have high frequency, any frequency. It depends on what type of modulation we want to do. Okay, this is my carrier signal. Can I write it now? This signal is message signal, this is my carrier signal. Okay, CT. Now what will be my, this is important now, what will be my final output? That means final output will be phi ASK. What will be my phi SK? So because now what will happen when the digital signal and the carrier signal is mixed and we need it through a digital mixer, then what will happen? When it is 0, that means when it is low voltage, no signal will be passed, it will be off. When it will be 1, that means the signal will be passed, that means it is on condition. So let us say I can just make some like this. I can make like this. When you are making, just make it nicely with a ruler, please. Okay, when I make like this, what will happen? When it is 1, that means a signal will be passed. Okay, sorry, there will be, because it is, let us see. Okay, let us make it here as well. Okay, now I can draw it. So the first one is 0, that means there will be no signal passed, that means it is off. Now again it is 1, the signal will be passed like this. Okay, now it is 0, it is off condition. When it is 1, we'll just see what the carrier waveform looks like and we will make it. This will be off, and now it will be, it starts from here, so the carrier signal will be like this and it will be off. Okay, So basically when we are making the phi sk, it is on off key. Okay, this is on here, this is on, and this is on. That's why this mode ASK is also known as on off key. Okay, I hope you understand this. Now next one is frequency shift key, or I can write FSK. Okay, next is frequency shift key. So in this one, first of all, again, why it is used? It is used to convert digital data into analog data. Okay, like ASK, it is also used to convert digital data into analog data. What is the definition of this? Definition: frequency of carrier signal varying with respect to amplitude of message signal. Okay, now basically we are talking about the FSK, that means we are talking about the frequency. So frequency of carrier signal will vary according to the amplitude of the message signal. Now again, what we are going to do, we are going to make the carrier let us just make a waveform. Okay, and I can just drop this form here. Okay, and now I need a carrier waveform. Let us copy this. Okay, so we have made a carrier waveform here now, like this. Okay, so what can I do? I can just write here, it is empty. Now this is FC1. FC1 means it is a carrier of some frequency, maybe high frequency or the low frequency. Okay, now I'll make another carrier here. So maybe I can make the low frequency like this. Okay, this is my another carrier. I can write it FC2. Okay, let us say FC naught. Okay, now if I need to make phi FSK, what will be the final signal? Can anyone guess? Yes. So what will happen is, at 1, wherever there is 1, the signal will be high. Means, now just make these lines. Okay, now what will make, at 0 with the low frequency will pass. Okay, so this carrier will pass at 0 because the first one is 0. So I'm just passing this carrier. Now at 1, the carrier with the high frequency will pass like this. At 0, again the low frequency, then at 1 it will be high frequency, then at 0 low frequency, then at 1 it will be high frequency, and at 0 again it will be low frequency. So this is my final signal, phi FSK. So please remember what we are going to do. At 1 the signal will with high frequency will pass, and at 0 the signal will low frequency will pass. Okay, and if you need to write the mathematical expression of phi FSK, then it will be m naught t cos omega c naught t plus m1 t cos omega c1 t. Okay, that will be my phi fsk. Now the third one is phase shift key. That means it is PSK. So for PSK, the definition is carrier phase is varying according to the amplitude of message signal. Now carrier phase is varying according to the amplitude of message signal. It's very simple, like we did it in let us again make the okay, let us just copy this whole thing. Copy. Okay, yeah. So this is my carrier signal and the message signal and the carrier signal. Okay. Now we need to make the final waveform. How do we do the final waveform? Let us make a line here. And if we do the final waveform, let us extend this line. So for PSK, what I am going to do is, I can just mark them here MT, I can mark them here CT, and this is my final phi PSK. So what will be my output signal? So at means 1 to 0, when it is shifting from 1 to 0, there will be phase reversal. Okay, so it is 0 here, so just we will see the carrier waveform is like this. Okay, this is 0. Now it is a 0 to 1, they are transferring. So we will not go like this, we will not go like this, we will just do phase reversal like this. Okay, now it is ending here, now it is 1 to 0 again. So we will start from this phase reversal. Now it is again 0 to 1, so we will start from this. Okay, now again it is a phase reversal, we will start from this. Now again there will be a phase reversal, we'll start from this and then this. So whenever there is a transition, there is a phase reversal like this. There is a phase reversal, here, there is a phase reversal here. Okay, so let us write here, whenever there is a transition either 0 to 1 or either 1 to 0, there will be a phase reversal. Okay, so this is the explanation of all the three type of modulation techniques. So amplitude, ASK, FSK and PSK. Okay, let us take an example. Okay, so very important example, you need to so let us say 1011, we need to transfer this 10110001. Okay, this is the question. We need to transfer it and we need to show the waveforms for ASK, PSK and FSK, and we can choose the carrier signal of our own frequency, right? So now first of all the question is 1011001. So we will draw the message signal. So it will be, see, the first one is 1, next is 0, next is 1, and another one is 1, and then there are two zeros, 1 0, 1 0, and then there is 1. So can I write it? It's like that: 1 0, it is 1, it is 1, 1 0 1 1, it is 0, it is 0, and it is 1. Okay. Now if I need to do it for ASK first, this is my message signal MT. For ASK, let us draw a carrier waveform. Okay, carrier waveform, we can choose our own frequency. You can just choose high frequency, very high frequency, low frequency. It's up to you. Okay, so let us say this is my carrier signal CT. Okay, now how to make the waveform, the final waveform? ASK. So what we will do, we'll just make, okay, let's try the okay, I've just made these ones. You can make the dotted lines. I'm just removing, that means they are the dotted lines, not the solid lines. Okay, you can make them straight. I'm just making them here, that's why it's like this. Okay, tell me now what will be final my phi ASK. Phi SK is known as on off. That means at 1 there will be a transmission of the signal, at 0 there will be no transmission. At 1 again there will be a transmission, at 1 there will be a transmission, at 0 there will be no transmission, and at 1 again there will be a transmission. Okay, do you understand that? So this is the phi SK. Now I have to do it for, we will take the same message signal. This is my message signal, and I will do it for my PSK. Okay, for PSK what will happen, I'm just extending this line. Okay, I'm just making it dotted. Okay, so for this, if I need to make for PSK, then obviously I'm just taking the same carrier and I will draw for PSK. Now tell me for what will happen. Whenever there is a transition, there will be a phase change, otherwise there will be no phase change. Now I will draw for 1 first. So this is my carrier wave like this, and after 1 there is a transition. That means I'm going to do the phase reversal like this. Now it is 0, then again there is a transition. I will do the phase reversal. Okay, now after 1 it is 1. We will not do any phase reversal and we will go like this. Now it is 0 and 0, but there is a phase reversal now. So it is 0 and 0. So we will go like this. And again there is a phase reversal. So we will go like this. So you can see wherever there is a transition, there is a phase reversal. Okay. So this is my waveform for phi PSK. Okay. Now if I need to make for phi FSK. So what will happen? I am just taking this carrier waveform CT, and for phi SK, let us say this is my FC1T. This carrier is FC1T, and I can make the another carrier. Let us make another carrier here only. Let us make another carrier for very low frequency like this. Okay, and let us say it is FC0T. Okay, so now there are two carriers and we need to make a final waveform for phi FSK. So what will happen, wherever there is 1, so high frequency will pass. Okay, so the first one is 1, so I will pass the high frequency like this, and then there is 0, that means low frequency. Okay, let us show the low frequency with another pen. It is low frequency, and then again 1 and 1. Okay, so what will happen, 1 and 1 means it's a high frequency for 1 and 1. Okay, now after 1 and 1 there is 0 and 0, that means again now it's a low frequency. Let us show with a different pen. It is low frequency, and then again it is a 1, then it is high frequency. Okay, so this is a final waveform from phi FSK. Low, this is low. When it is 0, then it is a low frequency. Okay, so these are the final signal for phi ASK, FSK and PSK. So in exam you will get a message signal and you need to transfer this message signal. Okay, so yeah, so that's all for this topic. Thank you.